Hello everyone and welcome to my YouTube channel. My name is Marios and today I will be talking about generics, which is a new feature introduced in Go 1.18. So many developers had the feeling that one important feature that was lagging from the language was generics, and based on feedback that was received from the Go team, they understood that need and they have recently released Go 1.18 introducing that feature. So we are very excited for having that feature in the language, and goal of this tutorial is to try to understand what is generics, try to see when we can use it, and also try to understand the mechanism behind it. As part of generics, the Go team introduced 3 changes in the language, and I wouldn't say changes, they introduced some new ideas to the language, and one of them is type parameters. So we will try to explain what is a type parameter and how we can use it. They have also extended the existing implementation of an interface so that it can be used as a type constraint, and a type constraint is an important implementation detail for generics. And the third one and last is type inference. So when we invoke a generic function, then the language can infer the type based on the parameters that we provide to it, and we will also have a look over there. As a first step, we need to understand what kind of problems generics solve, and one common issue that we had prior Go 1.18 was that we had to create duplicate code for functions that had similar implementations, but they were using different types. So a common example is when we wanted to calculate the sum of integers or float numbers. So we had to specify a function to calculate the sum of integers and another function to calculate the sum of float numbers. Generics solve that problem by introducing an abstraction, a generic abstraction that we set placeholders of the type when we develop that function, and we passing the type of that generic function when we invoke it at the first time. Let's demonstrate of what we have explained by writing some code. So what we need to do here is to set the implementation of a function to calculate the sum of integers, and I will call it sum integers. The argument will be nums, and that will be a variable of integers. I also want to return an integer, so which is the sum, and I initiate the value of it, and now I need to iterate over the numbers and increment the sum. So that's how we calculate the sum of integers, and I will also try to set the implementation for floats, and I'm changing the type, and let's call those functions. So you see the output over here, 6 and 6.3. And the problem with that is we have 2 functions with a very similar logic, but with different types. And generics solve that problem. So the Go team, to support that idea, it has to introduce some new concepts, and one of it is type parameters. And a type parameter essentially is a placeholder of the type that we want when we invoke that function. So when we develop our function, we set a placeholder, right? And that placeholder is filled, we will fill that placeholder when we invoke the function for the first time. So here I can remove some floats, right? So I want to generalize my function, and I can call it sum, a more generic name. And type arguments, we specify type arguments using square braces before the signature of the function. So within the square braces, I need to set the placeholder t in that case, and a list of types that we are allowed to set for t, and in our case is integer and float 64. So I can change int to be t now, and we will feed that value when we invoke the function over here. So I'm replacing sum of integers with sum and sum of floats with sum, and as you see we get the same output using the same function which has been abstracted using generics. If you have noticed, we are not passing the type for my placeholder, and Go is still able to calculate the sum, and the reason behind it is type inference. So the actual syntax of Go for calling and invoke a generic function is by setting square braces, and within those square braces you're setting the type of your placeholder. So here I need to set int, right? I still get the valid value here, 6. But when I hover on top of the integer, my ID says to me that you have an unnecessary type argument, right? And the reason of that is because of type inference. And how Go works internally is that it sees the list of parameters that I'm passing to it, right? So I'm passing 1, 2, 3, which are integers. So in my signature, I'm accepting a variable of t. So t presumably will be an integer, and that fills all the placeholders here. So when I invoke it, it says, okay, what I'm returning will be integer. What I'm initiating the variable as will be an integer, and that's enough for Go, so we can ignore setting the type for our placeholder and still calculate the right value. There are cases that we need to explicitly set the type of our placeholders, and that's when Go is not able to determine the type based on the list of parameters that we are passing to it, right? So such case would be when the return type is different, right? So here I want to return R, and for that reason I need to set another generic over there to which will be related of what I'm returning from the function, and I'm also setting integer and float 64, right? So Go complains here because I need to typecast it, right? So I'm typecasting it, and you see that cannot infer R, and the reason is that, okay, now I need to explicitly set to Go of what type that I want to return, right? So there might be a case that I want to set int and return float 64, right? So we see that now it doesn't complete, right? I can set int, and here I can set, okay, I want float 64, right? But what you return to me is an integer, right? So we see that 6.3 is converted to an integer, which is 6, and for those cases we may need to explicitly set the type of our placeholder, but most of the times Go is able to determine your type based on the signature of your function. Now let's look more into type constraints, which we have already used, but we want to explain them a bit more. And as we said, to create a generic function, we need to set type parameters, and type parameter is specified using square braces, and within those square braces we set the placeholder of the type that we want, and right next to it we set a type constraint. So a type constraint tells the list of types allowed for that particular placeholder, and in our case we are using a union, which is specified using the pipe symbol, and we want either an integer or a float 64. Another structure which we can use to set a type constraint is surprisingly an interface, which has been extended to support that functionality. Until now, we were thinking of interface something that types had to implement. So a type needed to have a list of methods to implement a particular interface. Now that definition slightly changed, and you can think of an interface or as a list of types that implement that particular interface, right? And the syntax of creating a type constraint using an interface is pretty much the same. So here I'm setting, I want the interface of number, and within the curly braces I need to set the types that I'm allowed to use. So I want to be integer and float 64, and I can simply replace what I have over there with number. And as you see, Go doesn't complain, and it successfully runs what I have over here, returning the right output. So this was the end of this tutorial. I hope you enjoyed it. We tried to cover some of the new ideas and mechanisms on Go 1.18, which are related with generics. I hope the information that I provided to you is enough. If not, please share with me what else you want me to cover. And also, if you have topics that you want me to cover, please share them with me as well. I'm really interested to get some feedback on what you want me to cover, and also like some ideas that you may have. Until next time, hope you enjoy your time and speak to you soon. Thank you.